Okay, so today we're going to be talking about laboratory equipment use and general safety. Biggest safety tip is safety glasses. When you're in the lab space, they need to be worn at all times. Never take these off if you're in the lab space. Okay. Other safety stuff, you don't want any baggy clothes, right? So if you're wearing a hoodie or something like that, you want to take them off. Or if you have really baggy sleeves, maybe roll them up. Okay, and if you have long hair, you want to put it up because you don't want your hair to get into things. So kind of as a tip, always have an extra hairband. You know, I normally say on lab days, which is Thursday, Fridays, but we can kind of do labs throughout the entire thing. So always have a hairband if you have long hair, just in case you need to put your hair up. Right? Now we're going to go over, equipment use and safety. Okay, the first thing we're going to talk about is glassware. And glassware is the flasks and the beakers and other things that we use, right, that are made of glass. So glassware, before we use it, so for example, this beaker, right, we want to inspect it. And I know it's dirty, I'm sorry. But what you're going to do is you're going to check the rim and see if there's any chips or cracks. Okay, you're going to check the walls, right? You're going to see if there's any cracks in it. You're going to check the bottom and see if there's any cracks. We don't want to use glassware that has chips or cracks in it because they can break on you, especially if you're going to heat them up. Right? So always inspect your glassware before you get started. Since we're talking about glassware, let's talk about the types. There are beakers, right? And I have several different sizes of beakers. All right, so I have larger ones. This is a 400 milliliter ones, all the way down to little baby ones, 50 milliliters. Okay. Glassware that we have, with the exception of the graduated cylinder, which we'll talk about later, is good for holding chemicals and liquids, and it's good for heating chemicals, liquids, things like that, and it's good for mixing things. So, for example, I might need to hold water for something. Okay. Now, one thing to keep in mind with glassware, all right, this particular kind, we have measurement marks on the side. So with the beaker along with the flask, okay, these measurement marks are estimations. We don't use these to actually measure our liquids. So I'm not going to use this to measure 100 milliliters of water, okay? Because these are inaccurate, okay? Most beakers are inaccurate, plus or minus 5%, okay? And what that means is, if I was trying to measure 100 milliliters of liquid in here, which would be right there, okay? Even if I got it right on that mark, that could be 95 milliliters or it could be 105 milliliters, because 5% of 100 is 5. Right, and so plus would be 105, minus would be 95. Right? And when we measure things for labs, we want to be as accurate as possible. Right? So we don't use these to measure out our liquids and things like that. These are just estimations. Right? You may use these if I say how much liquid did you end up in your beaker. Well, then you can use this to get that estimation. But you don't want to use it to measure your liquids. Okay? And so, like I said, we have our beakers. We also have flasks, same thing, good for holding liquids, good for mixing, good for heating, and these are estimations. What makes these useful, all right, the slanted sides actually makes it easier to mix things by hand, okay, and the narrow top makes it so you can put a stopper in it, and that way you can save things for later, or if you use a stopper with a hole in it, you can control, right, the flow of things. So we'll get kind of into that. That's glassware. So again, just to check, inspect it for cracks and chips. Okay, do not use it for measurements. All right, and since we're on the subject of glassware beakers, this is a glass stirring rod. Same thing. You want to inspect it for cracks and chips because you don't want to use one because as you're using it, it might break. Right? And what these are used for is for mixing chemicals. So for example, if I was going to make a saltwater solution, okay, so I just mix my salt water, but if I just wait for it to dissolve, that can take forever. And so I can mix it to speed up that dissolving. Now, generally when you mix, you want it on a counter, right? You don't want to hold it up in the air like I am. And you want to mix it. So there we go. All right. And so then you can use this to mix. Okay. And you can do that until it all dissolves. All right. Something else that glass stirring rods are good for is if I'm going to transfer liquid, I can take my glass stirring rod, put it across the top, and then you can use that as a way to aim the flow of liquid where you want it to go. The reason we use glass for things like mixing and holding is because they're not going to react with the chemicals that we put in them. It's referred to as inert, right? And so that's why we have a glass stirring rod versus a wood stirring rod, or or a metal spoon and things like that, because those could possibly react with the chemicals. This isn't going to react with the chemicals. So that's why we use glass. Okay, let's get on to the subject of measurement. If you're going to measure the liquid volume of something, we use graduated cylinders. And just like the beakers and other glassware, I have multiple sizes. Okay, as you can see here, these have the marks up it just as well as the beakers and flasks that we covered. Okay. These are way more accurate, and so this is what we use to measure our liquid volume. So if I needed, say, let's say 30 milliliters of my salt solution, okay, I can pour it in here, and I'm going to add it. I'm going to keep adding it until I get close to my 30. Okay. When I get close but not going over, right, that's when I want to set it down on the countertop, like so. Sorry for all the shaking. Here, what I can do is now get down at eye level and see what their measurement's at. What you're looking at, okay, is this right here. So that kind of what looks like a thick line at the top of it is called the meniscus. All right, and yes, there's one in your knee. This one's different, okay? But this is what you're looking at, okay? And I'll kind of put a better picture of a meniscus right here so you can see what I'm talking about. Okay. But basically, the way this is formed is the water around the glass, all right? So the water that touches the glass that makes up the tube is attracted to it. And so it actually kind of crawls up the side of the glass just a little bit, and it makes a curve, okay? And as you look at that curve, it kind of looks like, a double line, all right, or a thick line, all right? And again, I'll have a picture right here, all right, for you to look at. So let's look at this real quick. Sorry for the shaking, all right? But you can see here how it looks like you kind of have a top of the water, and then this little bottom part of it, and then you get to the clear liquid. You want to measure to the bottom of the meniscus, right? So I'm going to set it down on the ground so it's not all wiggly from me holding it. And then, at least for me, what I like to do is when I get close, I like getting a pipette, which is what this is, okay? And I can use that to slowly add water until the bottom of that meniscus gets to my measurement. In this case, it'd be 30 milliliters. Okay? And then that way I know I accurately have that much volume. Another thing about safety, keep your lab space clean. All right? Don't look like this, where you have stuff scattered everywhere. Okay, and things like that, because you can more easily knock things over. Okay, we talked about measuring liquids with a graduate cylinder. Now let's talk about measuring mass. To measure mass of something, we use a digital balance, which is what this is. Okay? Just like everything, you want to inspect the equipment that you're going to use. So you kind of want to just make sure, the biggest thing is check the cord and make sure that it's not damaged, right? You don't see any broken wires or anything like that. Okay? To turn on the digital balance, right here, you hit the on button. You wait for it to load. Okay? While we're waiting for this to load, let's talk about what's over here. This is what's referred to as a weigh boat. Okay? We do not want to directly measure chemicals on the scale, right, or on the digital balance. We want to use something to hold that, because most of the time when we weigh something, we're going to go use it somewhere else. Right? Plus, you don't want to get my digital balance all dirty and things like that. So we use weigh boats, and I have two kind of shapes. I have this one here, and then I have this one here. Okay, and the way we use weigh boats is you take a weigh boat, right? You want it to be relatively clean. You put it on the balance. As you can see here, this weigh boat has mass, right? But I don't want to include this in the measurement of my chemical. And so what I can do is zero it out. Right? So now I'm not measuring the mass of the weigh boat. Then I can use my chemical scoop here. Right. As you can see, it has kind of two sides. It has this pointier end, and it has this blunt round end here, right? And then these raised sides. You use the pointy end to scoop up chemicals. Okay. And then you can use that to place it in this weigh boat and see how much you have. So let's say I need 5 grams. Right. And you can see here that this measures, that little G means it measures in grams. So I need 1.5 more. So I'm going to add more. Oop, I went over. And then you can use the scoop, just harder with one hand, to remove some. There we go. See, so I could use some to remove some. If I was close, let's say I want it 5.2 grams. Okay. One thing you can do is get some on your chemical scoop like this, and then you use this finger here and you tap it so that parts slowly fall off instead of pouring. And that allows you to add a little weight at a time until you get what you want. And then you can put the rest back in there. Okay. So remember, with the digital balance, okay, with weigh boats, you don't want to weigh the mass of the weigh boat. And so you can put it on and you can hit 0 and 0 it out. And you can actually see if I remove this, this weigh boat is 2.3 grams. All right. So you 0 it out, all right, and then you use your chemical scoop to transfer your chemicals. Okay, continuing along with measurements, another thing that we might need to do is measure the length of something, right? And you're going to use a ruler for that. Now, in science, we use the metric system because that's the international standard here. So if I was to use this, let's look at the ruler, okay? The way this ruler is set up, if you look at the side that has the little mm here, that stands for millimeter. Okay? And the way to read this ruler is each of these big lines, so 1, 2, 3, these are all centimeters. So that's 1 centimeter, 2 centimeters, 3 centimeters. If you counted them in between each line, so like from 1 to 2, there's 10 small lines, with this medium one here being 5 small lines. Okay, there are 10 millimeters and 1 centimeter, right? And so if you counted those, there would be 10. Right. And so there's 2 ways you can read this. You can read this as 10 millimeters, or you can read this as 1 centimeter, right? And let's say I was 2 lines past the 1. I could read that as 1.2 centimeters, or I could read that as 12 millimeters. Right, so if I was to measure this box, okay, make sure I'm lined up here. Okay. I can see right here, hopefully you can too, that I have the 9 here. It goes past the 5, and then it's 2 lines past that. So that would be 5, 6, 7. So this box is either 9.7 centimeters or 97 millimeters. Okay. And so in this ruler here, okay, there's 30 centimeters, right? Or there's 300 millimeters. Right, so that's how you would use a ruler to measure the length of something. Okay, first up we have the hot plate here. Okay. Most of my hot plates have 2 controls. One control controls the stirring, right, which I demonstrated in class, and one control controls the heat. And just like a stove, the higher the number, the more heat there is. The higher the number on the stirring, the faster it stirs. So before you use the hot plate, even if it was already sitting here from a previous class, what you want to do is inspect it. So you want to check the top. I know it's dirty, but a crack in this would be very obvious, right? A lot of times it looks like a piece of hair laying across it. So if you see a crack in it, you don't want to use it. Okay. You also want to inspect the plug or the cord. And so you want to check the cord and make sure there's no melted parts, no cuts. Make sure you don't see any exposed wire. Okay. That way you know that you can safely use this device. Okay. If you need to plug it in and unplug it, make sure you, I don't know if you can see that. There you go. Make sure you grab it by the plug to do it. Don't yank on the cord, right? Don't yank on the cord. Grab the plug to plug it in and unplug it. So my inspection's done. I'm ready to use it. All right, so when we're using hot plates, right, if you haven't been around, right, so like if we're first starting or something like that, especially if you're not the first class of the day, always assume that this thing is hot. And so one way you can kind of check is using the back of your hand and just getting close, but not touching. Please don't touch. I don't want you to burn yourself, right? But the back of our hand is more sensitive to temperature than the palm of our hands. Right? And so you can use that and just kind of see, is it on? Always assume that it's on until you check it, okay? So I can place my beaker on it. I can turn on my hot plate and I can wait for it to heat up. I can also use my thermometer to check the temperature. Now, one thing you can see on this thermometer, or a couple things, hopefully you can see this. There you go. Right there's a C. That means that this thermometer measures in degrees Celsius, which is again the scientific standard, right? And so right here, 100 degrees Celsius is the temperature at which water boils, okay, at sea level, right? And then here you can see 90 and then you can see 5, right? That means 95, okay? So, all right, and another feature is this little rubber thing here. What that's for is not for you to mark a measurement. It's for when you place it in a beaker, which that one's too high. Okay. When I place it in the beaker, it keeps it from rolling around. Right? That's why it's shaped like a triangle. And so that way I can keep it all in one spot and I'm able to do my reading. Okay. Sometimes we need to heat things up and then we need to pull them off. Right? And when that happens, what you want to do is you want to turn off the hot plate if you're done using it, and you're going to use these. These are beaker tongs, and you can use these to grab the beaker, pull it off, and you can set it onto the counter. Okay, these counters are heat resistant, so it's okay if you put a hot piece of glassware here. And again, if we're using hot plates and things like that, always assume that the glassware is hot because it's not going to look hot, right? We don't get glass here hot enough to change color. And so again, you want to inspect it before you touch anything, right? So when we're using hot plates and things like that, always assume that things are hot and check them before you touch them, okay? If you need to move hot beakers, use beaker tongs. Okay. If you need to move hot test tubes, so let's say I had a test tube in water, okay, and I was having to heat up the test tube, okay, I can use these, which are test tube tongs, to grab my test tube and pull it out. And I would have a test tube rack to put this in, which, yeah. Okay. So just to recap, inspect top and cord for any damage, right? This controls the heat. This controls stirring, which we'll probably not use in class because I don't have a lot of those stirring things, right? The stirring magnets. Always assume this is hot and check with the back of your hand, okay? And if you need to move something hot, such as a beaker, you use the beaker tongs. Okay, the next thing as far as heating things up is a Bunsen burner. This is a Bunsen burner, okay? It has a hose on it. Right, the Bunsen burner itself, it has a valve down here on the bottom, right? That if you loosen it up, which is what I'm doing here, it allows more gas through. Or if you tighten it up, it lets less gas through, okay? And then this little valve on the side controls how much air is coming in, and that changes the characteristics of your flame. Helps make them bigger or smaller and things like that. Okay. To use a Bunsen burner, first you want to inspect the hose, make sure that there's no nicks. All right, so here I can see that this fabric is coming off, but if I inspect the tube underneath, I don't see any damage. Okay, and you just keep checking, everything looks good. So I can take my hose and I can plug it into the gas just like that. Okay. The way these gas taps work is all the way over like this is off. All the way over like that is also off. Okay. This is fully on when it is directly in line with the tube. Okay. We rarely use it with it fully on. Okay. And this right here is a striker. Do not play with these, right? The flint, which is this piece here, right, that makes the strike, right, the spark, these are expensive. And if you sit there and play with them, you're going to make me have to buy new ones. And I can't afford to buy new ones all the time. Okay, so to use a Bunsen burner, you want to, like I said previously, we want our hair up, and this one especially, right? And don't touch it like I am because it's probably hot. I'll stop doing that. You want your hair up because this is open flame, and if your hair comes across that, your hair will catch on fire, right? So always have a hair band so you can put your hair up if you need to. But what you're going to do is you're going to turn this on just like a quarter turn like that, right? And then you can use the striker to light it. And actually I need a little bit more. And there we go. That is a lit Bunsen burner. And then you can use either the valve here to control your flame, so little, big, okay, or you can use the valve down here to control it. Okay. And that's how you turn on a Bunsen burner. So just to do it one more time, turn on the gas tap, about a quarter turn there. Take the striker and you squeeze above the Bunsen burner. Okay, and then that is how you light it. Okay, there's two ways that we heat things up using a Bunsen burner. The first way is using the ring stand here. That's what this is called, the ring stand. We put an iron ring on it. So that's what this is. And this is really simple. You just use this to tighten it, all right? And you can move it where you want. And then you can, loosen it, move where you want. You can tighten it back up. And then this right here is called wire gauze. What this allows is it gives us a platform that we can put a beaker on, right? Or some other thing that we're heating, okay? And it allows the heat to come through, and most of the heat is transferred to what you're heating and not to the platform that it's sitting on. And just like anything else, right? You inspect your stuff, right? You turn your gas tap on a quarter turn. You use your striker to light it, okay? And then I can start heating up this beaker with the Bunsen burner, okay? Sometimes we need a lot of heat really quick, and this is the fastest way to do it, okay? Sometimes we need things to burn, and we need a Bunsen burner to do that because it gives us a good flame, okay? So that's why we might use a Bunsen burner versus a hot plate, because it takes a hot plate a while to heat up. Okay, so that's one way we might heat things, using an iron ring and iron gauze to heat this up. And again, I'm using hot things, and so I need to assume that everything is hot. So if I need to move this beaker, I'm going to carefully use my beaker tongs to pick it up and move it to the counter, all right, or the lab bench. Okay, another way we might heat something up is, again, using the ring stand. And this time we're going to use what's referred to as a test tube clamp. And the same way, you can tighten and loosen this, all right, and attach it to the ring stand. Right here is where a test tube goes. All right, and so I can slide the test tube in there, and then I can tighten it up. Okay, so to put a test tube in, I can slide the test tube in, kind of squeeze the clamp, and then I tighten this wing nut right here. Okay, and a few things hopefully you can see. All right, you can see that my test tube is angled. Okay, this is to make it so you can rotate it. Right, and so I'm just keeping it from rotating. Right. You can see that the test tube is angled. Right, I don't want it to be straight up and down like this, because when I heat up the test tube, then I'm also heating up the test tube rack. This rubber stuff right here will burn, okay? So I want to angle my test tube. That way I can heat up just the bottom of it, but not the whole thing, okay? I also want to give myself room up top. And the reason that is when I need to take the test tube out, I can use these to hold the test tube while I loosen the rack. Okay, and so you got to give yourself room for this to touch, grab. Okay, and just like with the iron, what we've been covering, right? Bunsen burner, quarter turn on, light it, okay, and there we go. Right, and so then I can use this to heat up the liquid in that test tube. Okay. Another important safety thing is never point the opening of this towards where somebody's going to be. Okay, and so this is pointed away from me. It's not pointed towards the walkway where somebody might be going on. And the reason that is if this spontaneously boils, right, or a chemical that we're heating up pops, right, we're not getting things shooting out at people. Okay, so always point it away from you. Always tilt it so that you're only heating the bottom of the test tube. Okay, a few more lab safety tips. You never want to have chemicals and liquids unlabeled. That way you know what they are and you know what you're mixing. Right? Never mix chemicals in a lab or in my space, our space here, okay, without first me okaying it. Right? And that's for your safety. Right. So some ways that you can be safe as far as labeling chemicals. Okay. One thing is you might want to, if we're weighing out chemicals into weigh boats, something that you can do. Okay. You can put your chemical on a piece of paper and you can write what it is. And I don't know if you can see that label, but I labeled it iron, okay, because that's what that is. Okay, also you can label beakers. And so this beaker was my salt solution. And so I can put salt on there, all right? Or the chemical formula, NaCl, okay? Using a dry erase marker. We can also use permanent markers because on the glass, it's easy to clean off, right? But label your beakers, label your chemicals and weigh boats. That way, when you get to the next step and you have to mix the salt with the water, you know what is salt, right? And you know what is water. Okay, some safety recap. Always inspect your glassware. All right, you want to check for chips, you want to check for cracks. Always inspect cords and other things for what you're using. So the hot plate here. Keep your lab space clean, because if you don't, you knock things over and you make a mess. I did that on purpose, obviously. Speaking of that, this little ring here should be left at the top because it protects the graduated cylinder if it falls over. Right? Always clean up spills and other things immediately so that they don't spread or people don't get things on them. Always wear your safety glasses. If you have long hair, always wear it up. Right? A few safety things here in the classroom. This is the eye wash station. Okay, you use this paddle here to turn it on. And what you're going to need to do, hopefully you don't get things in your eyes because you're wearing safety glasses. But what you're going to need to do after you turn it on is you're going to have to hold your eye open as you put it in the water. That way, because our natural reflex is to close them. Okay, and you want to leave them open, all right, so that you can flush them out. There's also the safety shower. Okay, it's controlled by this here, all right. This is only for major emergency spills, like if you dumped an entire beaker of acid on yourself, right? You pull this, take this, and you pull it down, all right? And water will come out of the shower, okay? Please do not play with this. It'll make a mess. Okay? And then the fire extinguisher. Okay, the fire extinguisher for our class is over by my outside door. Okay. Fire extinguisher. I will demonstrate in class how to properly use the fire extinguisher. If you weren't here in class when I did that, please ask me and I will demonstrate it again. But it's an important piece of safety equipment. If there are any spills or anything like that, please notify me immediately, right? So I can help, ascertain what it is and how to clean it up properly. That way we can all be safe. All right, good luck.